Hi there, how you doing? I want to talk to you a little bit about some exponentials. First of all, I just want you to understand the basic form of some of these graphs. First, we're going to look at y equals 2 to the x. Hopefully you understand the phrase exponentials and you've heard it somewhere, and it conjures up the idea of something increasing pretty rapidly. That is the idea behind this. We're going to start off right here, and we are actually never going to be able to touch this axis. And as we come through, it is going to just sort of take right off and start increasing very, 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 very rapidly. It's kind of the same idea here with this graph, except seeing that 2 is negative, you should understand that this is a reflection over a horizontal line. So imagine taking this graph and just kind of bam, flipping it down there onto that side. So we're going to be looking like this. It's not going to be increasing at a great rate. It will be decreasing at a pretty rapid rate. So we're never actually going to be able to hit. And then all of a sudden, it's going to jam straight down there. Actually, not straight, but it's going to continue to drop down pretty rapidly right there. Now I want you to take a look at y equals 1/2 to the x. Similar idea, except now you can kind of think of it as a reflection over a vertical axis. So imagine me taking this graph right here of this exponential and flipping it that way. So we're going to be looking like this a little bit. And then it's going to be a very, 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 very similar idea as what we talked about with these two when we're talking about y equals negative 1/2 to the x. We're going to be coming in here and looking something like that. Should just kind of solidify your rules of exponents and raising a fraction to an exponent or raising a whole number to an exponent and really what happens. Dealing with that positive or negative, that's a secondary issue on top of that. So let's take a look at y equals 2 to the x minus h plus k. That's the general form of this. If you've watched me previously, it is opposite, same. But in this case, dealing with our exponential, it is going to be opposite, same, plus 1 because we are going to have an asymptote. So our locator point will be h, k plus 1. That's going to get you there every single time. You will have an asymptote. I'm just going to go right ahead and tell you what's going on with this one. We have an asymptote at y equals k. And that is my starting point with the asymptote. So now I'm going to show you really what's going on and how we're going to graph these. So let's see, y equals 2 to the x plus 1 minus 3. So I can come through, I can draw my set of axes here. And then I take a look at this. My starting point is going to be my asymptote. The asymptote is right there on the back. The asymptote is behind on the end. I don't know if that's an easy way for you to remember this, but it seems to work for me. There is the asymptote right there on the back. So I start with y equals negative 3. So I graph that, and I put my asymptote down at y equals negative 3. My graph is never going to be able to hit that line, and I see that my 2 is positive. Thinking about those shapes of the graphs on the previous page that we just did, I have an idea that my graph is going to come and start shooting up something like that. So now, if you were going to take the same approach and do opposite same, if you were going to take the same approach as previous graphs, well, you would have a tendency to say negative 1, negative 3. That would be opposite same. That is excluding the plus 1. So let's just say you forgot the plus 1. Well, you can go opposite same, so negative 1, negative 3, and that would put you right there. And I'm looking at that, and hopefully you see a serious issue with that. You cannot have anything on this asymptote. So if that were to be your point and you put it there, you're going to have some major problems. Hopefully the bells start to go off and you're like, okay, I can't be there. So my next logical step would be to maybe add 1 to that. Now if I add 1 on my x, I'm still going to be on my asymptote. So let's add 1 to my y, and it takes me there. So I would really need to add 1 to that. So my locator point, my launch point would be -1, -2. That's where my graph starts. And if you want to make this graph more accurate, you could come right in, just like any graph, you could get more points. Well, if that's my point, I know it's going to be getting closer and closer and closer and closer and closer and closer to this asymptote as we go this way. So any points that I pick to the left of my launch point, those are going to be ending up giving me fractions. So I can just kind of get away with getting it closer. If you need accuracy, you can put those points in. But for graphing, sketching purposes, we could take a look here. So the next value I would put in would be 0. If I substitute 0 in here for x, 0 plus 1 is 1. 2 to the first, 2. 2 minus 3, -1. And you could continue this process with 1, 2, 3, 4, however accurate you need this graph, you can continue on. For the purposes of what we're doing, I know I can never hit right here. That's where it's going to start to turn, and it's going to become steeper and steeper and steeper, and there is a pretty good solid little graph of what we've dealt with. Now, we have our asymptote. Let's deal with domain and range. Domain. If I start here, I'm looking at my x values and I slide across, I'm hitting it from -infinity. Keep hitting it, 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 and I'm going to continue to keep hitting it to positive infinity, because as this graph goes up, it continues to get wider and wider and wider. I know it's going to take a long time, but it does go wider. Domain, all real numbers. Range, slightly different. If I'm working my way from the bottom up, I first encounter my graph here at this asymptote, which is -3. So I start at -3, but I'm not actually hitting -3. I'm getting so super duper close, it is crazy. Therefore, I cannot include that point of -3, so I use parentheses. And as I continue all the way up, I will hit my graph to positive infinity. And that is also with a parentheses. That's an example of a rational. Hope you enjoyed it. Excuse me, exponential. Hope you enjoyed it. Have a nice day.